Today on Engineering Newswire, we're flying rockets through the northern lights, sticking giant Earth catheters into geysers, and taking the fastest bike ride in the world. The Raht Racer is calling itself the fastest pedal ride in the world. This guy he's a pedal enthusiast. He's a bicyclist. And this pedal ride can reach speeds of up to 100 miles per hour. Currently seeking funding on Kickstarter, Ratmobile, the company behind the vehicle, features some top-notch acting in their product video.
Hi. Rocky here's guitar is plugged into an amplifier. If I turn down the volume knob, I turn down the amount of amplification. If I turn up the volume, the amount of amplification goes up.
They even rope in Scotty Olson, the proud inventor of rollerblades.
The proud inventor of rollerblades.
To get up to speed, the Raht Racer's pedals are connected to a patented generator system. At higher pedal RPMs, you charge the battery pack, and at lower RPMs, your energy goes towards powering the onboard electronic systems, such as the gauges, lights, and computer. A fly-by-wire system, the computer is what calculates your pedal input before sending the information to a motor controller. A throttle is used to accelerate and decelerate, and you don't have to pedal if you are feeling lazy, as the Raht can also function solely as an electric vehicle. This thing also has air conditioning, a rear seat and trunk, and is safer than a motorcycle with a reinforced carbon fiber body, roll cage frame, seat belts, and even an airbag. The company is currently working towards mass production, and the first generation of the Raht Racers are expected to cost between $35,000 and $45,000. But at that price point, I will probably just stick to the Ziggle. Besides, I'm still pretty mad that they cut me out of their Kickstarter video.
If I unplug his guitar...
Don't unplug me, bro.
Oh, sorry.
Anyone who has seen the Northern Lights, otherwise known as Aurora Borealis, knows that they are incredibly breathtaking. The lights are a result of highly charged electrons from the solar wind interacting with elements in the Earth's atmosphere. Unfortunately, the lights also negatively affect power grids and communication and navigation systems. Basically, electron clouds that form during the day over North America are being drawn across the Arctic into the Scandinavian region by the Northern Lights. When this happens, serious interference to navigation and satellite systems occurs. In order to gather data that will predict space weather, researchers from the University of Oslo launched the ICI-4 rocket from Andøya Space Center in Norway on February 19th. Instruments on board the rocket took measurements while passing through the Aurora Borealis. Ground-based instruments confirmed that the rocket was on target to fly through the Northern Lights. However, because the target was moving at about 1,000 meters per second, the data collected by the rocket will need to be thoroughly analyzed to make sure it did fly through the lights. Those who travel in the northern region by land or sea require these navigation systems to accurately convey data. Researchers at the University of Oslo hope their findings will give us better understanding of why these interferences occur.
Researchers at the University of California, Berkeley wanted to know more about the ins and outs of geysers.
Fascinating natural phenomena. 3 million people go to Yellowstone, they watch geysers erupt, and they all ask why. And we don't know the answer to that question.
How they work, why they work, to gain insight into volcanic eruptions, which are similar, but, you know, a lot less accessible and deadly. That cannot be good. Yellowstone National Park, home to more than half of the world's geysers, won't let you poke or prod them, only surface measurements. Something about national treasures or some other nonsense, but in Chile, yeah, get up in there. So in 2012, the team traveled to the Atacama Desert for 6 days to essentially stick a giant Earth endoscope and catheter into the geyser known as El Jefe. You know, in the past I had the same name. Researchers probed El Jefe with temperature and pressure sensors and correlated the findings with above ground measurements from seismic sensors and tilt meters. They also submerged video cameras to watch the conduits and chambers below. Using their findings, the researchers built their own geyser upon their return. Like in a lab. It's much smaller. I call it El Jefecito. Made of glass with a bend, it erupts periodically. Though not as regular as its inspiration, El Jefe. But it turns out that the underground bend is the key to the geysers. It traps steam and heats the water column. The column essentially boils from the top down. More field studies are planned to better understand below ground processes. I just hope that we make the list of volunteers. Make an excellent team building field trip.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode.